Today we're going to talk about virtualization, and I'm going to show you how to install a Linux virtual machine on Windows step by step. I'm Leo and this is my channel, Leo Tech Lab. If you don't know it yet, take a look at the introduction video. Let's go. Okay, so the context is this. I have a Windows server that I want to enhance with extra capabilities of a Linux system, and basically I decided to install a virtual machine so I could benefit from both at the same time. My requirements for this virtual machine are as follows. To be part of my home network with a dedicated IP address for ease of exposure and management of services that I will have running on that virtual machine, so that I don't have to manage port forwarding, for example. Also, to support USB Passthrough, so that I can access at least a webcam and my 3D printer from my VM, to provide the best performance possible and free of charge. To validate this, the objectives for this video are to install a Linux virtual machine on Windows and to run an application on Linux that streams video from a USB webcam connected to the virtual machine. Okay, so in order to meet my requirements that are again here on the screen, so to allow the VM to access the home network, to enable it to have USB pass-through, to have good performance and to be free, I narrowed down my hypervisor options to 3. Microsoft Hyper-V, which is a Type 1 hypervisor and it's free with Windows Professional. VMware Player, it's a Type 2 hypervisor, but it's free for personal use. And Oracle VirtualBox, it's a Type 2 hypervisor, it's also free and is open source. By the way, for more information on hypervisors, you can watch my introduction video to Docker, links will be in the description. So, after some testing, I came to the following conclusions. Hyper-V doesn't allow direct USB pass-through, although there are more complicated workarounds that use USB over IP, but with less performance and extra complications, such as having to compile a new Linux kernel from source to enable support for the USB devices. Okay. In the pros category, it is in fact the best performance out of the 3 hypervisors, which is no surprise given that it is a Type 1 hypervisor. Regarding VMware and VirtualBox, so our Type 2 hypervisors, VMware Player enables direct USB pass-through and with very good performance, at least in my testing. VirtualBox allows direct USB pass-through, but the performance is not acceptable when compared to VMware Player. In my personal case, the webcam was extremely slow. So conclusion, I selected VMware Player to be the hypervisor of choice. Okay, so this is the plan. We're going to start with our Windows server with Windows operating system already installed. And we're going to first install VMware Player on it, our Type 2 hypervisor. After that, we're going to configure Linux virtual machine to be used with the Ubuntu server Linux distribution. Okay, this was what I selected, but you can use whatever Linux distribution you are more comfortable with. A side note here, but a very important one, this tutorial assumes that your Windows server is connected to your home network using a wired connection, not Wi-Fi. Okay, I will explain this further on in the video. After that, we're going to install the Ubuntu server per se, the operating system, and we're going to configure remote access to it by a command line using SSH, because Ubuntu server doesn't have a graphical interface in its minimal form, and that is the way I'm going to install it. After that, we're going to configure the USB pass-through to the webcam to the VM so that the VM can access the webcam. After that, we're going to, in Linux, run a Linux video streaming application that is going to use the video from the USB webcam in order to stream video. After that, we're going to test that video stream by accessing it using another computer on our home network, okay, with a browser. After that, we're going to do a couple more steps to make our setup more robust, okay, such as to be able to configure our virtual machine to launch services on startup. In this case, we're going to demonstrate this by having our video streaming app to always start on a VM startup. After that, we're going to have an optional step, which is to enable shared folders between the host operating system, in this case Windows, and the Linux virtual machine, in order to be able to easily access files from different file systems. Okay. After that, we're going to launch our virtual machine on Windows Startup. Okay, so similar to what we've done in case of the services on the virtual machine, but in this instance, we want to configure our virtual machine for itself to always start up every time our Windows server is either started or restarted. Okay, let's start installing VMware Player on Windows. But before we do that, we need to ensure that we have virtualization enabled in the BIOS or UEFI of our computer. We can quickly confirm if virtualization is active in Windows using the Performance tab in Task Manager. So I'm going to open Task Manager. Performance tab is this one. And down here, as you can see, I have virtualization enabled. Okay. If you do not have virtualization enabled, we need to access our computer BIOS or UEFI to activate it. Although it is different for each manufacturer, we can usually access the BIOS or UEFI by pressing a specific key when your computer is starting up. Usually it's the delete key or one of the F keys, the function keys. If you have a newer computer with UEFI, you can also access it using the Advanced Startup option in Windows. Let me show you. So Advanced Startup, here it is. This is the same thing as going to Settings, System Recovery, and Advanced Startup. And let's click on Restart now. Okay, please wait. So this will give us the option to restart our computer and access the UEFI user interface, which will allow us to activate the hardware virtualization. Okay, so troubleshoot, select this one, then advanced options, and here, UEFI firmware settings. This is the one we want. And here we go, restart to change UEFI firmware settings. So if we press restart here, you will then access the UEFI user interface of your computer, and you will be able to activate the hardware virtualization option. Okay, just don't forget to confirm that virtualization is active in the Performance tab of Windows Task Manager. Okay, now that we have enabled hardware virtualization, and given that we are going to install a Type 2 hypervisor, we don't need to have another hypervisor installed on the system. This also ensures that there are no conflicts between different hypervisors. As such, we'll make sure we disable all Windows virtualization options, including Hyper-V. In this installation, I will use Windows Home, okay, but you can use Windows Professional as well, without a problem. The difference is that Windows Professional has more options to disable, okay? So let's go into Windows Features, turn Windows Features on or off, and let me show you. Let's expand this. Okay, these are the optional features that you can turn on or off in Windows Home. Okay, This list is longer in Windows Professional, and I'm going to show you that in a bit. But first, let's go through these and see if there is anything we need to turn off. So, legacy media prints, virtual machine platform, this is one of them. Okay, turn it off. Windows hypervisor platform, turn it off as well. Mine are already off, that's fine. And Windows subsystem for Linux, so this is the WSL2. Okay, turn this off as well. I guess for Windows Home that's it. Let me show you if you have Windows Professional. I have a screenshot here. Okay, if you have Windows Professional, you have a lot more features, and let's see which of these you should turn off. So containers, this is an option for Windows containers. Hyper-V, virtual machine platform, Windows hypervisor platform, these are the same as Windows Home. Windows Sandbox, turn this off as well, and Windows subsystem for Linux. Okay, so if you are running Windows Professional, these are the options you should disable. Okay, let's start by downloading a VMware player and Ubuntu server as well. So let's go to www.vmware. Oh, it's exactly this one. www.vmware.com/go/download player. And it's version 17.5.1. It's the latest version. I've already confirmed that. And we want the Windows 64-bit operating system one. Download now. Okay. Let's go ahead and download Ubuntu as well. So Ubuntu server download. Get Ubuntu server. No, thank you. Okay, we have the Ubuntu server version 24.04 long-term support. That's fine. Let's go for this one. No, thank you. Okay, so this is going to take a little bit. I'll return when the download is over. See you in a bit. Okay, let's install VMware player. Downloads, here it is. Double click. Let's start the installation. Yes. A little slow today. Okay, next. I accept. Next. Installer detected the host as Hyper-V or device/credential guard enabled. Okay, I think I know what this is. I think this has something to do with I'm using memory isolation here in core, memory integrity. Yeah, I think this is it. I'll talk about this later on in the video, but do not install Windows Hypervisor Platform, okay? We just disabled it in the previous section, so do not install it, just click Next. Install to enhance keyboard driver. I don't think we need this. Add VMware Workstation Console tools into system path. Yes. So this will enable us to run some executables in the command line. So keep this selected. Next. Check for product updates on startup. Seems fine to me. And join the VMware Customer Experience Improvement Program. No, thank you. Next. Just start menu for me, please. Thank you. Next. And install. Okay, it's done. Finish. Okay, let's run VMware Workstation for the first time. Use VMware Workstation Player for free for non-commercial use. Exactly. Continue and finish. And that's it. Okay, we have VMware Workstation Player installed. Just go ahead and reboot the computer, just in case. And let's go on to the next step, which will be to install our Linux virtual machine. I'll see you in a bit as I am restarting my computer. See you later. Okay, let's create our Linux virtual machine. Let's launch VMware Player. and create a new virtual machine. Okay, first we'll select the ISO for the Ubuntu installation that we have previously downloaded. I store mine in c/vms/ISOs. Okay, it's this one over here. Select it and next. Give it a name. I'll call it Ubuntu server. Where will it be stored? I like to store my VMs in cvms. Okay, /Ubuntu server. Okay, so mine will be stored here. You can choose your own, of course. Okay, usually I use my VMs with at least 100 gigs of storage space, and I store my virtual disks as a single file in order to have better performance. As you can see, if you split them, you may reduce performance with very large disks. Next. Okay, now we don't want to power on the virtual machine just yet, and let's customize hardware. Okay, so my Windows server has 16 gigs of RAM, and it has a CPU with 4 processors, okay, with 4 cores. Usually what I recommend is to use either a quarter or half of your resources and dedicate those to your virtual machine according to the operational load you are expecting to have on your virtual machine. So for me, I will go with half. So I will give half of my RAM to the VM, so 8 gigs, 8,192 megs, and half of 4 is 2, so 2 virtual processor cores. Perfect. In terms of USB, I did several tests with the webcam, and I noticed that I got the best results with USB compatibility in USB 3.1. Okay, 2.0 gave me some problems, so I'm going to choose USB 3.1. And next we have the network settings. Okay, this is an important one. Okay, so by default, network settings usually are set as NAT, so network address translation. This basically means that Windows, or in this case VMware Player, is acting as the DHCP server for a private network that it sets up for the VM. Okay, exclusively. The VM will have internet access, but it won't be visible or accessible to the home network. Okay, and that's not my requirement. If you recall, to meet my network requirement, we need the VM to have a dedicated IP address on the home network. Okay. So given that, in my case, I have the server connected by network cable. Okay, so no Wi-Fi here. And this is important, and I will explain why in a little bit. I am able to choose VMware's bridged network mode. Okay, bridged mode allows the VM to have direct access to my cable network adapter, so that the VM can connect directly to my home network and have its own IP address, as well as control which TCP and UDP ports it will open to the network. Okay, this avoids me having to configure some kind of port forwarding, and it will definitely make network management easier for me. Okay, it also gives us the benefit, well, at least for me, it's a benefit of allowing me to manage the firewall of the virtual machine independently of the host system's firewall. Okay, this basically means I don't need to worry about managing the Windows firewall to expose services on my Linux virtual machine. Okay, so to do this, we come here to configure adapters, and we'll basically select our cable network adapter, which in my case it's this one, this Intel 82574L gigabit network connection. Okay, if you have problems identifying your network adapter, you can come here to settings and network and internet, and Ethernet. Okay, no Wi-Fi, remember, Ethernet. Okay, and down here in Ethernet, you can see the name of your adapter. Intel 82574L gigabit network connection. So that's how you know which one to select over here. Okay. Another important aspect, if you are using your home network, okay, do select this to be a private network and not a public one. Okay, it will make your life easier when consuming and exposing services to the network. Public networks should only be used when you are connecting to a hotel network or airport or cafes, something that you cannot trust. Okay, private networks usually are trusted networks, such as your home network. This will enable you to expose and consume services easier. Okay. Okay, so we have the bridge connection and we can close this and finish. Okay. Finally, and without going into too much detail, I just wanted to quickly note that in case your server can only use a Wi-Fi connection, okay, because for instance, you don't have a physical network port near your server, in that case, you will have to use network NAT mode, so the network address translation mode, and with port forwarding when necessary for service exposure, or you will need to use a second Wi-Fi USB dongle connected to your server. Okay, that way you will get two Wi-Fi adapters. The one that is usually comes with your server internally, and the second one that you will add via USB. And you will need to give your virtual machine exclusive access to it using USB Passthrough, just like we are going to do with the webcam. Okay, this means that the VM can then internally it can access directly to your Wi-Fi USB dongle and connect directly to your home network's Wi-Fi and have access to its own IP address. Okay, this is due to the fact that the Wi-Fi protocol, which is 802.11, only allows bridging client connections starting with the version 802.11ak from 2018. Okay, this is a great post that explains this in more detail. If you are curious, I'll leave the link to this post in the video description. Okay, but as far as I know, this 802.11ak has not been yet implemented in the various Wi-Fi products, either client products such as Wi-Fi dongles or routers. Okay, so that's basically why when you're using Wi-Fi, you have to use either the NAT mode or use external USB Wi-Fi dongle, for example. Okay, moving on. If you're using the Windows Memory Integrity Protection system that we've talked about earlier, you'll need to disable side channel mitigations to get the best performance out of your virtual machine. On my machine, I'm using Memory Integrity Protection. Okay, so you can come over to Windows Security like this. Okay, Windows Security. And over here in device security, core isolation, okay, memory integrity protection, okay, prevents attacks from inserting malicious code into high security processes. So in this case, I'm using memory integrity protection. So when we boot our virtual machine for the first time, we will see the side channel mitigations error pop up. So let's try it. And here it is. You are running this virtual machine with side channel mitigations enabled. Side channel mitigations provide enhanced security, but also lower performance. To disable, mitigation change the side channel mitigation setting in the advanced panel of a virtual machine. Okay, so obviously we want better performance. So let's shut down the virtual machine and disable this error. Okay, so to fix this error, you have two options. Okay, you can either turn off memory integrity protection, which affects Windows as a whole, or just turn off side channel mitigations at the VM level. Okay, if you don't need nested virtualization, meaning VMs inside VMs, I recommend keeping memory integrity protection enabled, okay? Because you will still have the whole Windows system protected in terms of memory integrity. And only turn off the VM side channel mitigations, okay? For nested virtualization, you do need to disable memory integrity protection, at least at the time of recording this video, okay? Unfortunately, the player version of VMware Workstation doesn't have a lot of options in the menus when compared to the paid version. So in this case, unfortunately, we have to manually edit the virtual machine configuration file to disable side channel mitigations, okay? So let's do that. Let's go over to our directory where we store our virtual machine, Ubuntu server, and here is the VMX file, which is the configuration file for our virtual machine, and we will use an editor. In my case, it's Visual Studio Code, but you can use a Notepad or something like that to edit it, okay? Here is our configuration file. And basically what we do is we scroll down to the last line and we add this, copy, paste. Okay, and we add this, ulm.disable mitigations equals true. Okay, let's save this and we're done, okay? Now let's try and relaunch our virtual machine and see that the error is gone. And there you go. Okay, no more error. We have successfully disabled side channel mitigations. And now we can start installing our Ubuntu server. Let's do it. So try or install Ubuntu server. We are going to select the minimum version of Ubuntu server, okay, to be as light and resource efficient as possible, okay. Whatever else we need to install, we can do it later using the package manager. Okay, let's start our installation. I'm going to select English, but I need a Portuguese keyboard. Of course, you will select what is best suited for you. Done. Okay, the minimal Ubuntu server install here. Search for third-party drivers. Why not? Doesn't hurt. So this is also interesting, okay? So we have an IP address of 192.168.153.130, okay? And if we come over to our Windows machine, we will see, hopefully, that that address is in the same space as our Windows server address. So it's just another machine on our home network. So our IP address for Windows is 192.168.153.128, and this is the same thing but 130, okay? So it's the same family of IPs, meaning this machine has successfully joined our home network. Perfect, exactly what we wanted, okay? So next, done. Proxy address, we don't need a proxy. Done. Now it's testing the Ubuntu mirrors closest to Portugal. The tests have passed. Done. Okay, just leave it as it is. This is to set up and partition the disk. Just use the entire disk. Done. Here the same thing. Use the default partitions. Done. Continue. Okay, your name Leo. Server name Leo Tech Lab. Username Leo. Password. Wouldn't you like to know? Again. Okay, done. Enable Ubuntu Pro. No, thank you. Skip for now. This one is important. Okay, so remember that we want to ensure remote access So we will select the option to install the OpenSSH server. This way we'll have access via the command line to our virtual machine from any machine in our home network. Okay, perfect. That's the plan. Done. No third-party drivers found. No problem. Continue. We don't need anything from here, so don't select anything and just click done. And now we wait for the installation to complete. Okay, the installation is complete, so let's select reboot now. And hopefully we will reboot our fresh installed Ubuntu server. So he's telling us he failed on mounting the CD-ROM. Please remove the installation medium, then press enter. Let's go to removable devices. Oh, it has already successfully done that. So let's just press enter. And this time, hopefully we will boot to our freshly installed Ubuntu server. And that's it. Let's try our first login. So Leo, password, and here it is, our freshly installed Ubuntu server. Let's check our IP address, 192.168.153.130. Perfect. So we are in our home network with a dedicated IP address. Okay, now that we have our freshly installed Ubuntu server, I also recommend installing VMware tools on our virtual machine to allow for extra functionality between host and VM, such as shared folders, which we will talk about in a bit, shared clipboard, better graphical integration in case of using a graphical UI, etc. So this is done by installing the OpenVM tools package, okay? So that's exactly what I'm going to do. So sudo for running this command as an administrator or as root. apt is the package manager, install, and the package name OpenVM tools. Okay, it's installing. Done. Okay, next, in addition to this, a text editor always comes in handy. Okay, personally I like Nano, so that's exactly what I'm going to install. Sudo apt install Nano. That's it. And connectivity tools also come in handy, especially on the server. I recommend installing the NetTools package, okay, which gives us access to tools such as netstat, for example. Yep, currently I don't have it. This is a very useful tool for validating open ports on our machine, for example. So sudo apt install NetTools. That's it. Now I can netstat -a. Oh, it's working, but too much information, so pipe more. And we can even see that our SSH server is running here on TCP6 line SSH. Perfect. Okay, now just to make sure our system is entirely up to date, let's update all the operating system packages using the apt update command, followed by the apt upgrade command. Okay, so he says there's one package that can be upgraded. Let's do that. apt upgrade. Done. Finally, let's restart our VM with shutdown -R for restart now. Once the VM restarts, we'll test the SSH access to it from another machine on our network. In this case, I'll use the same machine just for the purposes of the demonstration, but it's all good because I'm going to access it via its external IP address, or the IP address that it has on the home network. It's perfectly fine. It's just like I would be accessing it using another computer. I also recommend that you set a fixed IP for your VM to make it easier to access and manage. In this case, given that the VM is part of your home network and like any other machine, the fixed IP should be set directly on your home router. Now let's go ahead and test out the SSH connectivity because it has rebooted. Just let me figure out the current IP address, IP ADDR. So it's 192.168.153.130. It's this one over here. Okay, let's exit out of this session, minimize it. And now let's go over to our Windows terminal. By the way, if you don't have an OpenSSH client installed on your Windows machine, you won't be able to run the SSH command. For example, I don't have an OpenSSH client installed, so let's do that. And in Windows, you can type here optional features. Here they are in system settings. And come over here to add an optional feature. Just type SSH and you have two options, the client and the server. Okay, we are not going to install an OpenSSH server on our Windows machine because we already have one running on our virtual machine, remember? So we're just going to install the OpenSSH client so that our Windows machine is able to connect to the OpenSSH server that we have in our virtual machine and to any other OpenSSH server for that matter. So let's go and click next, add, and now it's starting to install our OpenSSH client. Now we wait for it to install. It may take a while depending on your system. That's it, it's installed. So let's check it out. Let's open a new terminal, either PowerShell or command prompt. It will work either way. Let's input SSH, and just like that, we now have our OpenSSH client installed. SSH Leo at 192.168.153.130. Okay, so this is the first time I'm trying to connect to this machine. Are you sure you want to connect? Yes. Oh, by the way, Leo is my username, at, and then the IP address. Now the password, and that's it. Okay, we have successfully accessed our server. Let me try the nstat. We have successfully tried our server, accessing our server via SSH. Okay, here it is. Perfect. Okay, now let's configure virtual machine access to USB devices. In my case, as you know, I'm going to use a webcam, but the process is valid for other USB devices as well. So with the VM connected, here it is. When we connect a USB device to Windows, okay, I'm going to connect the webcam to Windows. A pop-up will show up, okay, from VMware. To choose what to do when the device has been connected, and we have basically the option to leave it connected to the host Windows or connected to a virtual machine, and to make this change permanent. Okay, so currently I'm going to select connected to the Ubuntu and permanently. Okay, those two lines over there means it is already detecting my webcam, and if we come over here to removable devices, we can see it over here. Okay, and as we add more devices, they will show up here on this list. This check mark here means that the device is connected to the virtual machine. If it doesn't have the check mark, it is connected to Windows in this case. Okay, here I can disconnect it and connect it to Windows. And over here, I can forget the connection rule, meaning I can make it forget that it always has to connect to the virtual machine. Okay, so that extra option that I clicked, this is how I get rid of it. And after that, if I want to reactivate it, I have to take off the webcam and plug it back in again. And then the pop-up will appear again, and I will be able to select the remember rule again. Okay. By the way, you can only use a USB device connected to one of the two machines, either the virtual machine or the host machine. You cannot share the USB device at the same time between both machines, at least as far as I know, okay? So in my case, I prefer the option that keeps it permanently connected to the VM, because this way, every time you restart either the VM or your Windows server, the webcam will automatically reconnect to the virtual machine, which is exactly what I want to do in my scenario, and you may have a similar scenario as well. By the way, just to check that it is exclusively used, let's try to access the webcam when it is connected to Linux. We don't have a camera in Windows, but now we can manually remove it here. And so currently the check mark is gone, so it is connected to Windows and not Linux. That's why it says disconnect from host. This means that if I come over to the camera app, I should have access to the webcam. Perfect. But let's connect it again to the virtual machine. There you go. Those two lines again. Okay, so unfortunately, I have found that this permanent connection management system via UI and these pop-ups does not work properly. So in my tests, it often happened that my server would restart and the USB device would not automatically reconnect to the VM. As such, I found another way to set this rule for auto-connecting a USB device to the VM using the virtual machine configuration file, the VMX file that we already talked about. As such, I suggest you use this declarative system instead that I'm going to show you instead of the pop-up, okay? To this end, we need to add a new line, okay, for each USB device we want to permanently add to our VM, and we need to add that line on the VMX file. That line basically will tell us, or will tell the virtual machine to auto-connect device X, okay? But we need to identify what device it is, and we need to identify it precisely, okay? How is that identification made? It is made using something called the vendor ID and the product ID. They are two hardware identifiers that you need to get from your devices, in my case, the webcam. And after we have those two identifiers, we can write our rule. Okay, so how do we get those identifiers? You have two ways. You can either connect your device manually to your virtual machine, which in this case it already is. So I can ls USB. This basically lists all the USB devices connected to the virtual machine. And among these, I have this right here, my Crodia H2 live camera. That's my webcam. And over here, we have two sets of identifiers separated by this, okay? So you have 0C45, this is the vendor ID, and you have 636D, this is the product ID, okay? These both are in hexadecimal format, okay? But this is one way to obtain those identifiers. Another way, through Windows. So we have to reconnect it to Windows again. So I'm going to disconnect the webcam from the virtual machine, reconnect it to Windows. And now if I go over to Device Manager, I should have access to the webcam. Here it is. And I can go over to the Details tab and look at Hardware IDs. And there you go, okay? I can even put them side by side so you can see it better. See it over here? Vendor ID underscore 0C45, 0C45, and product ID underscore 636D, 636D, okay? So two different ways of how to obtain vendor ID and product ID, okay? Now that we have them, let's go ahead and edit our VMX file. Don't forget that in order to successfully edit the VMX file, you must have your virtual machine shut down, okay? Because every time it powers up or shuts down, I believe the VMX file is being rewritten, okay? So if you do make changes to it while the VM is running, when the VM is shut down, it will just overwrite your changes, okay? So bear that in mind. Let's shut it down. I can use this terminal, sudo shut down now, password. There she goes. Let's just wait for it to shut down. Okay, it's done. Now we can go ahead and edit our VMX file. C VMs Ubuntu server and the VMX file here. Let's edit this file. I'm going to use Visual Studio Code. Okay, here it is. Down here. Okay, last line. Okay. So what we're going to write now is USB_XHCI. This basically means use USB 3, okay? XHCI is equivalent to USB 3. And if you remember from previously, I explicitly said that I had problems with USB 2, and so I would use USB 3 compatibility mode in the virtual machine configuration. This is exactly the same thing, okay? I'm just saying use USB 3 on this device, okay? After that, I have to do .auto connect .device, and now a number. Starts with 0, so this is my first rule for my first device, so it's device 0. If you have other USB devices that you want to make auto connect rules for, you would add another line and just say device 1, device 2, etc. Okay, by the way, this is all from the product documentation from VMware. And now you say equals, and now is the time where we identify precisely what USB device we want to auto connect. So you will type VID for vendor ID 0x hexadecimal, and now the VID number, which is 0C45 0C45 space product ID PID colon 0x hexadecimal again, and now the product ID value 636D 636D, and that's it. Let's save our file and let's launch our virtual machine, and let's hope that the webcam will be connected on startup. Play virtual machine. Just warning me that I'm going to lose webcam from Windows. That's fine. That's exactly what we want. And this means it is connected. Okay. Oh, by the way, you can forget connection rule here, because this connection rule, it's not our connection rule. This stores this information somewhere else. I don't know where. But if you do click on forget connection rule, it won't affect our VMX rule, okay? The rule we just made in the VMX file. And just to prove that, let's shut down the virtual machine and let's check that our connection rule is still present. So let's shut down the machine. Can use its own terminal. Shut down. I don't need sudo. Shut down now. I don't need sudo because I'm in the terminal of the virtual machine itself. I'm not accessing it remotely via SSH, and that's it. Now let's go ahead and edit our VMX file and check that our rule is still present. Okay, it is here, but have you noticed that it changed position inside the file? This is what I meant. This file has been rewritten. Okay, so I think it's every time you start the machine or stop it, it will rewrite the file with the current state, I think. That's why you shouldn't edit this file with the machine running. Okay, always with it off. Okay, but here it is. Perfect. Over onto the Linux side of things, let's use the Windows terminal. We have to make sure that the webcam is operational here. So let's use the ls-usb command, which will list us all USB devices currently connected to our Linux machine. And here we have our webcam. Okay, it's using bus 3 and it's device 8 on bus 3, USB bus 3. Now, if we use the -T for the tree view of ls-usb, we can bus 3 device 8. Okay, we have 8 devices. The 4 devices named 8 or numbered 8. This is correct. Okay, so we have 2 video and 2 audio. Okay. They both have drivers loaded. Perfect. Okay, so this means that the devices are operational. This is for video and this is for audio. I do believe that the first device, the first video, is for the video stream itself, and the second one is for video metadata. Let's ls the devices directory /dev/video**. Okay, this basically means give me all the files that start with video inside the dev directory, and we should have 2. Here they are, so video 0 and video 1. So I'm pretty sure that video 0 is the video stream for the webcam, and video 1 is the video metadata for the video that is streaming on video 0. Okay, so these 2 files are our way of interacting with the webcam within Linux. Now, everything seems to be okay, but we need to test out the image. Okay, so given that we don't have a graphical environment installed on our VM, we just have command line, we're going to use an app to stream video from our USB webcam and make that video stream available on our home network, okay? Just like we talked about on the plan at the beginning of the video. One of those apps is Ustreamer, okay? You can search for it online. It's very easy to find. You also have tons of documentation around it, okay? Basically, this app does exactly that. It captures the webcam video and streams it in a browser accessible format. So let's install Ustreamer with apt install Ustreamer. So there's a package for it. Perfect. Now you can ask for help in the Ustreamer command, and you have the whole set of options here. Okay, I'm not going to force you to read all of this. Okay, I'm going to save you the trouble, but you can always look in the Ustreamer documentation if you want to. But basically, we need to run this. So let's see what it does in its default settings. Just type Ustreamer and enter, and let's see what we get. Okay, 2 problems. So let me just Control-C to get out of the program. 2 problems. So it is using device /dev/video 0 by default. Perfect. I think that's the correct device. But we have 2 problems here. First one, can't access device, permission denied. So it is not succeeding in connecting to the webcam feed due to permission. So we need to prefix Ustreamer with sudo so that we can run that command as root with administrator privileges. But we have another problem here because it is listening on this interface, which is the loopback interface, the 127.0.0.1. This is the localhost interface. So this is only available on the machine itself. It's not available for outside networks, and we want our stream to be able to be consumed in our home network by any device. Okay, so we need for the VM to be able to listen not only on this interface but on all interfaces. Okay, if a request comes from the network using the current IP of the machine, this one, 192.168.153.130, that it will also serve the stream. Okay, so for that we need to host our stream in 0000. This basically means host on all interfaces. Okay, so it will be listening for incoming requests on all interfaces for this stream, and I believe it was port 8080, but we will verify that. Okay, perfect. So no more error in terms of not being able to access the webcam. The sudo took care of that, and we are now listening on all interfaces on port 8080. Okay, so let's try and consume that stream. For that we need the 192.168. I forgot the IP address. 1 second, Control C. I need to take a look at the IP address of the VM, and 192.168.153.130. Let's copy this. Let's paste this here, and it's port 8080 exactly. Of course, currently there are no streams because the application is down, but let's turn the application back up, and here we go. And now we can access the /stream, and we're in business. Direct stream from our Linux virtual machine. And if I exit out of the program, Control C, we will lose the stream. Okay, so I can refresh this and the stream is gone. Perfect. So everything is working properly. We are now ready for the next step. See you in a bit. Okay, now let's talk about launching services at startup. So when we start up the VM to automatically launch services for us. There are several ways to do this. Personally, I like to use the cron application, which allows the execution of scripts when some events occur, in particular when rebooting the machine, for example. So I'll go ahead and install cron, and then I'll set up a rule to launch uStreamer each time the VM is rebooted. So let's go ahead and install cron, sudo apt install cron, password, installing, and that's it. Now I need to edit the rule file for the root user because I want to execute these services as root so that I don't have any problems with permissions. So sudo cron tab -e, okay, or -e. So this is the cron rule file for the root user. Now I'll add the event I want, and the event is reboot. So it's @reboot, and now in front I put the command I want cron to execute for me. And what I want to do is ustream --host 0000. Okay, so this is exactly, ustreamer. This is exactly the same command line that we were using, except we don't need the sudo prefix anymore, because this is already the cron rule file for the root user, meaning it will be the root user that is going to execute this command. So the root user doesn't need to prefix the command with sudo. He already is the root user. Okay, so let's save this file. Control X, Y, enter. Okay, for those of you who do not know the nano commands. And now let's restart the virtual machine and check if the ustreamer application is starting automatically with the VM. Okay, so let's do shutdown -R for reboot. And now I need to prefix shutdown with sudo because I'm trying to perform a shutdown remotely because I'm using SSH. Okay, this is the Windows console. Sudo shutdown -R now. Okay, perfect. Now the virtual machine is restarting. And here we have the IP address and the URL for the video stream. So what I expect to see here is as the VM is starting up, right at the end, Ustreamer will start automatically and we should see here the image of the stream. So fingers crossed. Oops, sorry. Nope, that's not it. This is it. And maybe there it is. Perfect. Okay, now we're going to talk about an optional step, but for me it's a very relevant one. It's shared folders. Okay, so shared folders allow sharing part of the host's file system with a virtual machine, so that both systems can have read and write access to those shared folders. This step is optional again, so you can skip this part if you're not interested in shared folders. However, personally, I always like to have external access to my VM's file system because I may want to save important files in the shared folder, which are still available on the host system even when the VM is either disconnected or even corrupted. Okay, in that way I can safeguard at least some of my important files, even if I lose the VM. So let's get to it. On the host side, we'll create a directory to share with the virtual machine. Okay, usually I use the C VMs shared directory. Okay, but you can use whatever you want, of course. C VMs. I will create a shared directory here. Shared. Okay. Maybe if I had more VMs, maybe it would make more sense to have this shared inside of each VM's folder, but in this case I only have one, so I won't complicate things. So this is the folder I want to share with the VM. Now let's go over to Player, Manage, Virtual Machine Settings, and Options, Shared Folders. Okay, and here always enabled. Okay, so I want to always enable this feature, meaning whenever I restart the VM, okay, I want the shared folders present again. So let's add our shared folder. Next, host path, it's the CWin VMs shared. It's this one, CVM shared, and the name inside Linux will be shared. That's fine. Next, enable this share. Yes. Read only. No, because I want write access as well. Finish, and that's it. Okay, so on the host side everything is prepared. Now we need to set up the shared folder on the virtual machine side. Okay, so to do this, actually let's use the SSH console. Yeah, it reads better and it has colors, so great. So to do this, let's create a folder to represent the shared folder inside the VM. So this is my home directory, which basically means it's home Leo. Yes, exactly. Okay, so I'm going to create here a host directory. Here it is. And inside this host directory, I want to have that shared folder from the host. Okay, how do we do that? We use the VMHG FSFuse. Okay, so this basically is an application from VMware that is included in the VMware tools package that we conveniently already installed. Remember that? Okay, so this basically is the application that is responsible for translating ext4 partitions into NTFS partitions, okay? And how do we do this? It's a long command line, but bear with me, okay? So sudo, and now the path to the executable. You'll understand why I'm expressing the full path in a minute. Okay, here it is. Now I want to connect all of the shared folders from host, and I do that by typing this. Okay. Next, what's the target directory inside my Linux file system? Home Leo host. So it's the directory you've just created. So I want that directory to connect to the shared one. And finally, I want to allow other users to access that directory, okay? Not just root. And that is achieved with this option here, allow_other. That's it. Password for sudo, and that's it. How can we test if this was successful? Let's check inside the host directory. We should have the shared directory, and here it is, which currently it's empty, but currently we have the two file systems linked. Okay, so this and this, they are seeing the same thing. How do we test this? Let's create a text file here in Linux, and let's open it up in Windows and vice versa. So let's use nano test txt. This is a test from the Linux side. Hello from Linux. Let's save it. Control X, Y, enter. And now let's open it up here in Windows. You can use whatever text editor you want. I'm using VS Code, and here it is. Perfect. Now let's test bidirectionality. So now I want to write in Windows and read in Linux. Okay, so this is a reply from Windows. Hello from Windows. Let's save this. Save, and let's see here using nano. Perfect. This is working. Okay, so bidirectionality is working perfectly. Now, given that the tests are successful, we need to ensure that sharing between the two file systems is enabled every time the virtual machine starts. Otherwise, we lose access to the files when we restart the VM, okay? How can we do this? We can reuse cron for this task as well, okay? So let's add one more reboot rule to enable file system sharing each time the VM is restarted. And now you're starting to understand why I've explicitly put the full path of the command here, because this is going directly into the cron file, okay? The cron rule file. So let's go. Sudo cron tab -e. First, I'm going to copy the command minus the sudo, okay? Remember, because we are already editing the cron rules for the root user, so we don't need sudo. And over here, we will add a @reboot, new rule, @reboot, please execute this. Perfect. Let's save. Yes. Enter. Now let's restart our virtual machine and confirm that the shared folders are correctly mounted. So sudo shutdown -r now, enter. Okay. And while the virtual machine is rebooting, let's add new stuff to the file. I'm adding new stuff here to the file directly from Windows. Let's save this. Okay, let's see. Okay, still restarting. Let's go ahead and ask for an SSH connection. It will give us one as soon as the OpenSSH server is ready to take requests. There you go. Let's input our password. Okay, we can minimize this. And now, moment of truth. Let's see if we have the shared directory inside. We do. And let's see the contents of the file. Excellent. I'm adding new stuff here to the file directly from Windows. So file sharing is perfectly functional. This step is finished, and I'll see you in the next step. See you in a bit. To finish the tutorial, we need to ensure that the VM is automatically launched every time our Windows server starts. This way, we know that whenever we have the server active, our VM will also probably be active. To do this, we're going to use VMware Player's vmrun command to launch our VM using the command line in the background. Okay, the command is as follows: vmrun -t player start, so start the VM. Which VM? The one that points to this configuration file. So C VMs Ubuntu server, the VM file that we edited earlier, remember? The VMX file, this one. And no GUI, so no graphical user interface, okay? So let's start the VM with the command. And okay, so vmrun is not recognizable as an internal or external command, okay? So what's the problem here? Basically, this is not working because it doesn't recognize the vmrun command, probably because it's not available in our system's path environment variable, okay? So let's quickly check our environment variables. Environment variables, edit the system environment variables. Now click here and let's check our user path. Nope. And over here on the system path. Okay, we have something here, but maybe this is not the correct directory for the vmrun file. So let's check it out manually. Let's open that directory. It's C program files, VMware, VMware player, bin. Yep, no vmrun to be found here. So these are Docker executables, something like that. Let's check the root folder because I do believe it should be here. And here it is, vmrun.exe. Okay, so in fact, it's this directory that we want to add to our path environment variable. So let's do that. Let's create a new entry here in the path, paste, enter, and let's move it up to be next to the other one. Okay, so now we have the bin contents plus the root VMware player directory contents. Both of them are in the system path. Okay, okay, okay. So now we should be able to recognize vmrun. Of course, it won't recognize it as of yet because we haven't refreshed the path environment variable yet. Correct? So we do need to close this command prompt and open a new one. This one will already have the path environment variable refreshed, so we can run vmrun and it will correctly execute. By the way, no point in trying to start the VM when the VM is already started. So let's start by shutting it down. I have the SSH still open here, so I can use this to shut it down. Sudo shutdown now. Password. And it's done. Now we can go ahead and try and launch our VM. Oh, by the way, how can we tell there is no VM running? We also have a command, vmrun list, that lists all the running VMs. And in this case, we have none. Perfect. So let's try the vmrun command once again. -t player start. Now the configuration file for our VM. Ubuntu server, Ubuntu VMX, no GUI, enter, and that's it. Let's see if it is running. It is. Total running VMs 1, and this is the one. Perfect. Another thing we can also do is take a sneak peek using the GUI. So let's see. Let's click on Ubuntu server, and as you can see, it is running because we have the pause button here. Let's dive in and see if it is starting. It is. Oh, by the way, that little warning that you just saw, it was the VM letting me know that it was taking control of the webcam. No problem, as expected. And that's it. So the VM is working. We were successful in turning it on. Oh, by the way, you can also turn it off. A very similar command. Instead of start, it's stop, and instead of no GUI, it's soft. Okay, so stop the VM. Which VM? This one over here with this configuration file. Soft basically means gently or gracefully. Okay, this basically is the ACPI shutdown. Okay, so this will send a signal to the VM so that it can gracefully shut down. So it will shut down the services. It will unmount correctly the USB devices, hard drives, etc. And only after that will it shut down, as opposed to a hard shutdown, which is equivalent of pulling the plug. Okay, so let's do a soft shutdown. And there it is. It received the ACPI shutdown signal, and there it goes. Perfect. Okay, the final step in our tutorial to automate our VM restart. And a simple way to do this is to create a bat file with the command line that we want to run, which in this case is the VM run player start here, okay, which starts the VM up. And then create a task in the task scheduler for this bat file to be executed every time Windows starts. From what I know, the VM is suspended when we restart Windows, and the VM run start command also resumes suspended VMs, so we're okay. Let's create the bat file. I usually put these files in the same directory as the VMs, okay, over here. Let's create a bat file. Let's call it Ubuntu server start on boot. Wait, boot dot bat. Okay, we have a bat file. Now let's add it. I'm using Visual Studio Code. And now let's copy the command that we want to run. Okay. An important thing to note here, I'm using a command prompt and not PowerShell, okay? PowerShell, if I'm not mistaken, usually uses single quotes instead of double quotes, okay? But in the bat file, you will need double quotes, okay? Because it's not using PowerShell. So keep that in mind. Double quotes, okay? VM run -t player start. Yeah, seems okay. Let's save it, okay? Now let's test it. Okay, so let's go ahead and navigate to the VMs directory. Here it is. Let's check if we have any VM running with VM run list. Nope. And now let's see if our new bat file can start up the VM. VM run list. Yep, it's working. Okay, so now we can create a task in Task Scheduler to run our bat file every time Windows starts. So let's do that. Task Scheduler. Okay, create task. Let's call it start VM at boot. Okay, we can use our current user here to run this task. Okay, this is a small home server. Okay, so I don't have any problems with this in terms of security. But it needs to run not only when the user is logged in, but whether the user is logged in or not. Okay, just like a service, kind of a service, not really, but kind of. Configure it for the most recent version, Windows 10. Okay, triggers. So when will this be triggered? At startup or at boot? At startup. Here it is. Okay, enabled. Perfect. So at startup, run this task. What does the task do? It runs our bat file. So action start program, browse. Perfect. C VMs Ubuntu server start on boot. That's it. It doesn't need any arguments and it doesn't need the working directory either. So we're good to go. Conditions, I think the default ones are okay. Yeah, and settings. Yeah, you can use the default ones. Okay, I think that's it. You need to input your password as well. Task scheduler will save your password inside the task so that it doesn't have to request it from you. And in this way, it's autonomous. Let's refresh it. And here it is. Start VM at boot. Ready at system startup. Never ran. No problem. So how can we test this now? A simple test would be to use another computer from our home network. Okay, to just access the webcam stream when we restart our Windows server. Okay, so we are going to restart our Windows server and confirm that the VM boots up automatically. However, given that I'm recording the tutorial on this machine here, it's simpler for me to just use a second user of the server to do this. Okay, so actually I'm going to use a different user, this one, other user, which is a normal regular user. It's not even an admin user. Okay, has nothing to do with this Leo Tech Lab user, which is the user in which the VM will run on, but it does prove the concept nevertheless. Okay, given that I'm not logging in at all with the user Leo Tech Lab, and yet the VM will launch anyway, or at least we hope so. So let's get to it. Let's restart our Windows server, and we're back, and our Windows server has restarted, and I'm not going to log in with Leo Tech Lab. I'm going to log in with other user. Welcome. Thank you, sir. And as you can see, totally different user. I'm even going to use a private window, okay, just to make sure there are no gimmicks, and we'll try to access our VM 192.168.153.130 in port 8080, and let's, whoa, okay, already perfect, and it's done. Excellent. So the Windows server booted successfully, the VM booted as well successfully. Our tutorial is done. And that's it. I hope this was useful to you. Please leave your feedback and share your ideas and opinions in the comments. And if you want to stay up to date with the latest videos, you can subscribe to the channel and click the like button. Thank you, and I'll see you next time.